Okay. We're getting there, I think. Yep. Okay, so, all right, so what happens, all right, so what is the multiplicity at x equals 2? 1. But when you had it up here, it showed that it was staying positive, right? So where should it be coming from? There you go. Does that seem a little better? All right. And then what happens? So what about as x goes to negative infinity? We'll take a look at that. Okay. So on the left side, what do we think?
So it starts up here, then switch sides. Then go follow the horizontal asymptote.
There we go. Well, it's not horizontal, it's...
Oh, sorry, slant asymptote.
And how did we find that slant asymptote? But shouldn't we do something to find the actual slant asymptote? What should we do? What's that? What'd you say? Say a little louder. Some long division. Okay, so that's where we'll find the slant asymptote. All right, so see if you guys can do that real quick because we're about to go back to our groups, okay? All right, guys, if you're finished, please go back to your groups. Looks pretty good. You guys look good. 7, you can have a seat. Uh-huh.
You say it's spade, but then have the image of a club.
Oh, because I changed it to club.
Yeah, so the club's supposed to do it, right?
Yes. Okay. You guys feel good? Think it looks good to me? Maybe one little tweak, but I want to leave it there on purpose. No. Stop.
I believe that this line should cross into the 3.
It's not
Okay.
to scale. It's not to scale.
All right. You want to leave that the way it was? Can you put back? Perfect. Okay.
Fine.
Yes, let's go back to our seats, please. Are we almost about to get it? Okay, so when you do this, you're going to get minus 3x squared. That's going to be right there, right? So it's y equals x. There's going to be a remainder, but it's x minus 3. You got y equals x. Okay, does that make sense? Okay. All right. You're going to have a seat. Just finish? All right. Looks good. We'll need to talk about that. Okay. All right, guys. Thank you. Have a seat, please. All right, group 3, if you guys can have a seat, please. Yep.
So, can you go to the next slide?
Yes, let me, I'm going to come back to that, though. Let me first talk about the answers back here. Without, like, saying ha-ha, or I think I'm right and you're wrong, does anybody see anything that might be a common, maybe, mistake in some of these answers? Look at not just yours, but look at everybody else's. Don't say it out loud yet. Just think about an answer. Okay, so just think about your answer first. Okay. Isaac, did you have your hand up? What did you see that was different?
The oblique asymptote is going through the origin instead of a different point.
Okay, and so I had to ask quite a few of you to show your work for that. And it's not always going to be like y equals x or something. So we need to show our work for it. And so we do get y equals x minus 3. So let me put the answer up here. So this is the work that we should have done over here. I just graded your daily quizzes. And I will say that most of you did it with long division and did it correct. Some of you did the box method and also got it correct. However, I think dealing with the remainder is a little bit challenging with the box method. So for that reason, I think some people made some mistakes. If you use the box method, you're less likely to make mistakes, I think, with long division. Okay, but it's still your preference, whatever way you want to do works. But can somebody explain to me why this is important to our graph? Okay. Yeah.
It shows us where the oblique asymptote crosses the x-axis.
So building on that, can we kind of add a little bit to how the limits and behavior come into play with that? Yep. Okay, so as x gets goes towards like infinity, it's showing you the right end behavior, because what happens to this, the remainder, as x goes to infinity? It becomes chump change. It becomes 0, right? So we'll be left with just the equation y equals x minus 3. So this is, both of these expressions are equal to x minus 3 plus 2x minus 20. So these three things are equivalent, as long as x doesn't equal 1, right? And so when I look at it in this form, we can clearly see that this will approach 0 at the end behavior. So y equals x minus 3 should be our standard asymptote. I saw some people commenting about how it should go through 3, 0. Who said that? Someone said that, right? Yeah, Jess? Right, yeah, you were saying it should have gone through 3, 0, right? And it should. Okay, so I do expect you, there's things that I don't need accuracy for, and there's things I do need accuracy for. And using the slope and y-intercept to plot y equals -3 as a y-intercept and go up 1 over 1, that's important. So I do need to see an appropriate slant asymptote. The whole, okay, again, we need to see our work for that. So does anyone have any questions on this at all? Let me shut the door real quick. Does anyone have any questions? Yeah, Emery?
I kind of forgot over the weekend. How do you see like when it bounces and when it is like when it does the like S thing?
Okay, good question. So when does it bounce back as opposed to changing from positive to negative? Can anybody answer that question? Yep. Okay, there's what word kind of describes that? Multiplicity. Excellent. So the multiplicity. So remember, here's a multiplicity of 2, right? So Emery, what does this factor, x plus 1 squared, what does that create? A 0 or a vertical asymptote? What is it?
Just creates the parabola.
Well, but does it create a 0 or does it create a vertical asymptote? A 0 at what location? At -1. So I see this -1 here, the multiplicity is 2. So that's where it's changing signs twice from positive to negative, but then back to positive. Okay? Does anyone have any questions on the graph? Yes?
The squared. Wait. Oh, but wait, is the squared for the x plus 1? That's the point on the graph.
That shows me right here the 0 at -1, because that would make this 0. And the multiplicity of 2 says it's going to change signs from positive to negative, but then a second time back to positive.
Yeah.
Okay? Yeah.
And how would I like differentiate that from just like another vertical asymptote?
Okay, so if it was on a, well, this is a 0, but if it was on a vertical asymptote, for example, at x equals 2, say this was squared, I would have gone from positive, instead of going to negative, it would have changed signs a second time, coming up here. Okay, so it would not have changed. All right, so over here, Janaya was nice and didn't erase it for me. I do want to make sure for test and quiz purposes that I'm clear about what would lose little points here and there. So like the slant asymptote needs to be correct, right? Do you see that this dips below that x-axis? It's minor. This one's not as big of a deal. But if I see like a gap between here and here, if I see a gap, like that's going into the negative zone. And that's an important concept, that it doesn't change to positive to negative. So make sure that the signs stay true. All right, at this point, I now would like you guys, this is what we're learning today, is solving inequalities. I said spade and I changed it to a club. So whoever had the club can write your answer to this, but use your graph to help you with this, solving the inequality, when is this greater than or equal to 0? So using your graph, this is what we're learning today, is how to use the graph to help us analyze when the graph is greater than or equal to 0. You might want to, I will post this on Canvas, but you might want to write at least this problem down in your notes so that you have to work with it. Yes?
I didn't get this ask question, but if there was, the reason why I asked that question at the beginning was because I thought that it was x minus 1.
Uh-huh.
So if there was, for example, if there was no x minus 1 up there, and it was just the exponent, right? And if it was x minus 1 squared, and then that can't, what does the x minus 1 cancel out?
So you're saying if it still stayed a whole, but it was x minus 1 was squared?
Yeah.
So I would cancel out one of them. So like one factor would cancel out from both. And when I plug it, so this would still be a whole because x cannot equal 1. But when I plug 1 in, I'll get something times 0. So this would be a 0. So instead of 1, 3, I'd have a whole at 1, 0. When you plug in 1, won't this equal 0? When you plug in 1 for x, won't that equal 0? So 0 times this will equal 0. So this will all equal 0. I would have a whole there instead of there. Well, no, instead of there. This is no longer there. It would be down here. Okay. For interest of time, what I want to do is talk about how this was important for graphing, was understanding when things change sign, correct? Positive to negative. And if positive and negative, if it's positive, what does it compare to 0? Greater than. If it's negative, it's less than. So what I want to do is I want to highlight this number, the x-axis as a number line for possible answers. And so from negative infinity all the way to negative 3, okay, I don't have any zeros or vertical asymptotes between here and here. It's all going to be positive or negative. Do you agree? Okay. And then from negative 3 to what value is it going to always be positive or negative? Negative 1. Okay. Be careful because 0 is a point we need to kind of think about. So I'm going to change this as well from negative 1 to 2. It's that vertical asymptote. And then from 2 to where? 2 to 4. And then the last interval would be 4 to infinity. Okay. Correct. The oblique asymptote, the only purpose of the oblique asymptote, Soren, is what? To describe end behavior. Yep. So slant and horizontal both have that property. It only depicts end behavior. All right. So, does that help us to think about our answer? Please everyone write down your answer, not just the person who has a club. Everyone write down your answer to this question. Yep. Yeah, well, take out paper and write your answer down.
So why does it like stop at why
At negative 1? Well, it could have changed. It changes sign there, right? So if it's greater than or equal to, we need to think about what happens there. Right. So our answer. So that might affect our answer, but right now those are the important intervals what we have to think about.
That's just for like the purpose of like
Yep.
So basically, you're saying that it would just be from the 0 to the midline, all the way down to negative.
Each one of those colors is a new interval for which I'm either all positive or all negative. And so some of those intervals will be greater than or equal to 0, and some of them will be less than 0.
Oh, because it changes the negative and positive, the end behavior.
Yes.
Oh.
Yeah. Mm-hmm.
What do we do if like one interval has like two
Well, aren't I breaking all the intervals up at zeros and vertical asymptotes? And isn't that the only place that can happen?
Well, what about the one from negative 1 to
From negative 1 to 2, that's all positive. So, the whole's an important thing. All right, good. All right, guys. Let's pause for a second. There's an important value up here we need to think about. So let's actually forget about something and then think about why we might have an error in our answer. Okay. So let's look at it from negative infinity to negative 3. Is that a part of the solution set? Because it's not greater than or equal to 0. It's less than 0. It's negative. From negative 3 to 1, is it greater than or equal to 0? Yes. Do I include negative 3 in that answer? No, because it's a vertical asymptote. So -3. Do I include -1?